Hey, my name is Synaptic. I also go by Mark, and I'm a system automation developer, and I'm going to be demoing Context Compass. It's my repo that I built for help me manage using Codex and Gemini and hopefully Claude soon. So I hope you guys all enjoy this video, and if you like it, subscribe, and let's get into it. So let me explain what this is for and what it is. Okay, so this repo is a policy-driven context orchestrator. It allows agents to enter your repo. Doesn't matter what language it is. It could be Rust, it could be Python, it could be C Sharp, whatever you want. You essentially get to onboard the agent, set up roles, use the existing roles or set up your own. And the core reason why this system is important is because it solves a couple very crucial problems. With Codex and Gemini, Codex has its own different issues, and Gemini has its own issues. So I'm going to start with Codex. Codex, compact summarization, right? Or context compacting. With Codex, it happens at around like 280,000 LOC. And this event is a way for them to maintain low cost, right? The more tokens you have, the more expensive it gets. It's a quadratic relationship, okay? So at 100,000 tokens, costs X dollars. At 200,000 tokens, I think it costs 4 times more. So you get the point, right? At 300,000, et cetera, it's expensive, right? So that's me making an assumption, right? I'm assuming it has a lot to do with money. Probably does. Odds are that's why they set it up this way. So Gemini has a context window of 1 million. At least a 3.0 did, right? But GPT is, from what I understand, it's around 280,000, right? So Codex will wipe its context at around 280,000. And what that means is it won't 100% wipe everything. It'll summarize everything it can into a very neatly composed small packet of information, right? So if you gave it 200,000 LOC of things, it's going to remember a fuzzy of what it did. It's like you remember what you did 2 weeks ago on a Friday at 2 p.m. Odds are you got a fuzzy, right? You probably don't know. That's how Codex remembers things. Okay, if your memory's horrible like mine, you can't really trust that, or you can't really trust it. So now, yeah, so Codex, that's one of the features. It compacts. Instead of having to make a new chat, it compacts its memory, and you go. So, if you're working on a big code base, well, guess what? It just forgot everything. It's going to have to sprawl. It's going to have to read everything again. It's going to have to go out and scour your code base. Thousands or hundreds of thousands of lines of code. Another 100, 200,000 tokens gone down the drain, and your usage gets used up. So that's what happens. Now, if you have a small project, you won't have the same kind of experiences, but at around like 50,000 LOC, 100,000 LOC, 200,000, 500,000, a million. What are you going to do? Well, you're going to have to rethink your plan. You're going to have to work in smaller pieces or use this. So Context Compass, like the name implies, is a system built around managing context efficiently and intelligently. So attention board, right? So let's just start here. We got the attention board. These are the type values, okay? So there's literal state machines built into this thing. The attention board's a state machine. You're going to have tickets, tasks, stories, and epics. There's an artifact board, right? The compact summarization event. There are skills built around that. So Now, this isn't all automated, right? The agent can still drift, and often does still drift, right? You'll have instances where the agent will still forget things, right? After a summarization event, it's probably not going to remember a lot of these skills. Not 100%, but it's going to know of them. So the cool thing is with Codex, it remembers the attention board. It remembers to make tickets. Those actually persist, right? The onboarding, it might not always remember that it has to onboard again. Okay. So this is really great, right? Attention board. This is built so imagine it's working on a few different things you asked it to do: tickets, stories, epic, whatever. You have something set up. It's going through your repo. You wanted to implement this front end system, front end UI, and you're working through it. Boom, boom, boom. You're going. And now you're at a spot where, oh no, you're at 230,000 tokens. It's about to compact. What happens? Well, that doesn't matter because he's keeping notes. So that's the great part about this, right? Now, he's keeping notes here. Artifact board. Okay, if you have artifacts being built to go along with your tickets, it'll maintain that. So let me show you some of the example tickets here. Right, we have here's what it looks like. So you have time, status, IDs, and these tickets often bind to a story, and stories bind to an epic, right? And you have scope boundaries, state transition events, step checklist. So it's very, very detailed. This is why it's called Context Compass. Every single thing you're doing here is contextually important, right? Very, very important information. So here's one thing that's amazing: the microcycle. Okay. Now, when it's implementing a ticket, it investigates a little bit, documents, right? And then it goes, build a strategy and a plan, documents, implement, document, and then validate, document. Okay, so these are this little microcycle, or you can call it a workflow. It'll basically go and set up all of these important pieces for you. Now, Codex, with the newer models, it should actually pause and propose what it wants to do to you. Okay, it should do that with the skills I gave it. Now let's go back and look at a few more things. Okay, so example architecture. So we're implementing the C4 Simon Brown C4 unified modeling language style. It's just a way to model architectures, and we're implementing that here, right? So this is not a true example, right? This is just a very basic foundation, and like mine, for instance, is around. Um, I'll show you a repo later. It's around 75,000 LOC, and my SRC architecture is around 1100 LOC. And SRC component diagram, which is a different one, is around 1500. So it's nice because instead of reading all of your code, you can get, if you onboard the agent as an engineer type, it'll read these documents and it'll actually understand a lot about what's going on. So now, and it can build these too. So there's a role, design engineer. It'll build these documents, and then you'll have your own variations of these things. So here's an epic. Now, you have all this good stuff here, evidence data. Now, this is the best part, evidence data, right? So the way I have the core reason I built it like this was because I would go through a compacting event, and usually during that process, like Codex would be digging for an answer, like it's trying to implement something for me, and it gets to a spot where boom, we're at 200,000 tokens, and 220 is when it compacts. So it starts to implement. It starts to implement compacting. Everything it ran discovery on, its entire sprawl, useless, gone. So usually my model is I make an epic to run discovery on everything I want it to understand. And then it goes, reads SRC arc, SRC components, and then it sprawls, right? It makes the stories and then tasks to run discovery, boom, boom, boom. It's like it'll go through 20 different code files, jot down exactly where it found something. It'll jot down, oh, it's at line 51 to 70. And it's important because of this. And then it goes and does that. So it'll collect exactly what it needs, like 300, maybe 300 lines of code, right? It'll get exactly what it needs. It'll build a hypothesis. It'll build that out into the epic. And then when you need to actually use it, you wait till a compacting event occurs or you trigger one, and then boom, you then have got exactly what you need. You don't have to sprawl and waste 100,000 tokens. No, you just go and you hit it. You grab that 300 LOC and you go and you implement whatever you want to implement, right? And you test and do all that good stuff. So I think this is a good explanation of all this stuff. And then there's a little config here, a little YAML doc of everything that's going on here. So all the different roles and to read the README, like it's pretty good. Okay, so let's get into exactly what this looks like. So I got Antigravity up, and let me show you my my system real quick. This is what we're working on. So this is my system here. That's my SRC document, and so Melder is what I'm working on. It's a dependency graph runtime. It's similar to Dishka or dependency injector, or it's similar to Lagom. These three are pretty popular in Python, and we got some unit tests here. I'm still kind of lacking on these for this architecture. It's still pretty low. I got to add more here, but either way, you kind of get the big picture, right? There's a lot of code in this repo. We got a lot of code in here, so 76,000. And this is not counting tests, not counting interfaces, not counting all those things. If I was, it'd be a lot higher. Specifically just the prod code that's going out the door. So this is my challenge, right? And I'm building this alone. This is what I'm working on. So let's go over to, let me describe what tickets we have built for this exercise so I can show you what this is. So this is my SRC doc. That's pretty long here. So you got quite a few. You can see like these are very detailed. I'm not going to really go through. I haven't released Melder yet, so I'm not really going to show this off. A couple months I will. So you get the point though. So what we're doing now is I'm going to go to the tickets we built. So these are the actual tickets. So this is Gemini doing the work, not Codex. So Gemini is going to be our example for today. I'll do Codex another time. And you can see how detailed the ticket is. You can see all these steps here. And what was this ticket for? Investigate creation alt. Okay, objective. All right, so got some fact information here. It's saying, okay, so evidence is here at 141 to 600. Creation context hooks precompile string templates to avoid AST compilation per context, but still pay closure environment access overhead. So he's making an assumption that I'm not using abstract syntax trees, and for a specific reason. Okay, so he's making an assumption here, which is fine. So that's the guess there. And here we got more information. This is a different area. So you can see this is line 419 to 740, sorry, 799, and then here you have line 19 to 434, right? So it's going to pretty big documents here, right? This I think this one's like 2,000 LOC, and this one here is around like 1,000. So now it's making this claim. Creation context bottleneck involves dynamic Python source generation. It uses CodeGen and heavy dict to tuple cache key construction for socket shape and root position arity. Okay. So when I'm making my my DAG system, to actually execute the resolution of objects. One of the end results are going to be a socket shape along with other things. And he's kind of reading into that. So these are simply the tasks, right? These aren't even the stories, okay? So we go into a story now. Let's see how he did these ones. So anchors the task this. So he's basically saying here, um, risks. You got some duplication here. Enforced microcycle phases this. Acceptance criteria, entry gate. So I think he just built this as a proxy. I don't think he actually, maybe I'm wrong here. Retain as reference. Okay, let's see what these ones look like. Yeah, I think most of these he just built risks. Okay. So he just built these to implement the pattern, I think, in this moment. So here we have the epic. He's linking the ideas he's going to try, and this is specifically create initial epic skeleton investigations. Okay. So, great. Now, these are older tickets. In the newer version, it actually shows the ID for this. So, okay. Let's go ahead and get into this. So I've already done the boring stuff, and he's onboarded. Let's go to the top and show you. Okay. So with um, with Gemini, it's not like Codex. He has different kinds of features. Now, right now, Google has the benefit of using their own IDE to manage their agents, and it does great things. Like we have a step counter, something I don't have with Codex, and that means you can build events into things. So with Gemini, I built an event for it to re-onboard its general abilities at around 560 steps. Something I built into the system. So it'll constantly do that, and it'll remember its skills. So you don't have to do all of these things. You can customize this and set up your own where you might say, okay, I want to do this after 1,000 steps. I want to retain X skills. You might say, okay, I want to actually just implement these 10 skills at this area, and I want to make sure it retains these things. You can do that. You can set this up. With Context Compass, you can modify all this and set up your own strategies and your own ideas. The core features really are going to be the attention board, the tickets, the notations, the workflows, the unknown to known, the enums here you have for the types. Like all this stuff is crucial. So let's see what he does, right? We onboarded. So now this is cool. I have to certify him. So if I'm happy with the onboarding, he went through over like 70 skills. If I'm happy with that, just go like this, and he's happy. So I hope he's happy. He might be upset about that slash. Probably not though, but let's see. User certification. Okay, so what are we doing here? He is making a task to we don't need that. So no need for a task. Go ahead and read SRC architecture and SRC component. And I think, did we already do that? Yes, you already did. So he might have actually read it because it is one of the features for engineer. But I can't really see. Oh, here. I think he might have read it. I think he might have read it. Oh, no, he didn't. Okay, he's reading it now. So another cool thing about Gemini, great. I want you to now take the ideas we have in the epic that's active and map it to into an implementation plan. Utilize the SRC architecture and SRC components as your base context. Do not access the code you already have. So we're going to see if he can actually set this up without going into the code, right? He has enough data in the epic. One thing yeah, so he's going to go read it. And I think we'll have to iterate one more time, unless he goes and reads. Oh, he is reading other ones. Look at that. Nice. He's reading the other documents he made. And he's building a strategy. Okay, cool. Let's see. All right. What do we got here? So, okay. So he's suggesting that the core bottleneck is identified in phase 12 execution compilation, where dynamically generated Python strings are passed to exec compile, massive string building, and AST parsing overhead. Additionally, creation context suffers from dictionary caching, tuple packing overhead. Okay, those are the assumptions that were made during the analysis, right? So, okay, so let's talk about this. Opcode VM. Let's just see. So he wants to get out of CodeGen because CodeGen is slower. Okay. So, yeah, we can't use C extensions. Okay. So, does so that's an option. Now, we're gonna actually hit a decision point here just so I can demo this. We're gonna go ahead and do one of these options. I think, what about approach? I don't care much right now about, um, so we're gonna see. I want to see if I can make this a little bit faster. That's my goal. And I think it's much easier for him to do B. It'd be better for the demo. Okay, let's do it. Great. So let's focus on, let's see. Oh, it's identical. Okay, so what are the benefits here? Safety and maintainability. Slightly faster compilation. Okay, so you're claiming that we cannot use Python because we're so I think that our outcomes are pretty much we're basically at like the peak here. So now, just for the example, I've min-maxed this to like I don't really have too many more options. I think this idea of the AST. Okay, so we can't really use opcode because either other not use opcode because I don't work C++ or C. So AST trees and more maintainable. So let's implement that. Okay, so we're gonna. I don't want him to start planning yet. Let's talk more before we begin. Okay, so basically, I want him to talk. I have a clean. Yeah, this branch I can really not care about. So, okay, all right. So here's what I want. Okay, cool. So we've landed on a solution. AST is what I want. Abstract syntax tree, and so please move all the tickets and stories, tasks, epics to completed, and plan out a new epic for your implementation strategy. Build a story for each component. You need to upgrade and run discovery on how you plan to do it. Ensure you properly run code gen where we're doing a full benchmarks, P-core affinity, and I think it's called cogent deltas. Well, you know what? We'll just if this is not gonna, we're gonna add this to the repo here, cogent deltas and path profiles. I think that's what we want. Um, we can benchmark that, and so I'm gonna have to benchmark before and after, and then we can basically get a good readout on this one. Fully understand what he's doing, if it's worth it, or if it's just a waste of time. So I spent like 2 or 3, like I've been doing this for days. That we've really found no other enhancements. So this is my first time actually using Gemini for this. So let's just see what he does. You can use those benchmarks. Please output the artifacts, artifacts to text compass artifacts and cite them your tools and update the attention board with all your details. Then retest after you implement. So we have everything lined up. Go ahead and also update the YAML to set Synaptic Python Developer as a transient role and make general your default role. Okay, that's a lot of stuff, but he's gonna do that, and I think did I say before and after? Let's make sure he's just gonna do all that stuff. I'll just ask him to do it again after. What does he want to do here? Yes, he wants to move the tickets. Make sure you also update properly speed test before and after limitations. He's running the Python tests. Yeah. I hope this video is not boring because honestly, this is the gist of it, right? Like you're gonna have to deal with your agent. You're gonna have to make sure it works. So right now he's preparing the environment. He's doing the before and after stuff. I'm trying to get him to make the tickets so he knows that we can use those, and he's building the epic now. So he built the epic, and he set the step. This is his ID for the chat. Um, he's basically setting up all of this good stuff here. Milestones for success. So it's pretty good. He's setting up artifacts, which are the cogent outputs. Now let me show you those. Yeah, let me just grab that so you can see what he's actually doing. He's building the task tickets now. He's basically setting everything up. Now, as you can see, right, if you're using Codex and you went through compacting, it wouldn't matter. Like you would not have any problems. You'd be good. And this is all tied to the epic, and the story is right here. Like this is the best in your repo stuff you can do, right? Like of course you could have Python tools set up or PowerShell scripts, or you could have Bash scripts set up to do all this stuff. But like, what if you just want something simple, easy, right? You just throw this in your repo, do your thing. It's not bad. You just put it through. So he's trying to run tests on. Let's see what he's doing here. Oh, in the directory. He's trying to run the test in that directory. He's just running the whole thing. He's just running all of them. Okay. It's going to take you forever there. Sure. This is fine. He's doing his thing. Now, of course, you can give Gemini to do git commands. You can give him to do all that stuff. So, attention board. Yeah, he's doing it. He is missing something here, though. So he's missing the event for onboarding. It looks like it was cleared out. He got rid of it. Yeah, I mean, honestly, I just wanted to experiment with policy only um, systems, and this thing's around 20,000 LOC of Markdown and like mostly Markdown stuff. There is some YAML in there, but it turned out good. Now I'll do another video later describing Codex, and I think that'll describe exactly what I've been talking about. You can't really put all of that into a video in the context of Gemini, right? This is still like with Gemini, when you get to step 2000, 3000, 4000, 5000, a lot of the old stuff gets truncated, right? So when you're really far down the line, they truncate over time. So, or maybe I actually do have Codex going here, I can actually talk about this. So here, let me demo Codex as well. Let's see. I'll put this in here as well. Why not? So get to run this. He's running unit tests. Okay, let me add this to here real quick. ESC out. All right. He's just working away on that. So he is implementing the abstract syntax tree. Let's see if he can pull that off. Okay. So I'm going to show you Codex. He's actually very close to compacting on here. So now here's some ideas I'm going through, and we're about to push through it. It's very similar. His system doesn't have the steps, doesn't have any of the other stuff. We're just talking about some ideas on how I want to improve my tools. So, okay, great. Ensure you document everything in your epics, stories, and tick the tasks. And I think he's in a compact at 75%. So that's why I think this is a good example. And then let's go back to, as he does that, we're going to switch back over to Gemini. And let's make sure we finish this off. So he's doing some more tests, unit tests. Now, this is a lot to do with like the fact that we collected information, we did discovery, we did all that stuff in a different step. That took 1,000 steps, right? So you're really seeing the end product of, okay, we got our info, we got everything we needed, and he's implementing it. Now, will it work? I don't know. That's up for we don't know that yet. So we're gonna see what he does. I want to maybe finish this video off with just him getting that part done, but I don't know if that'll happen. And okay, all right, let's try and trigger a compacting with this other one here. Okay, we're back to this guy. Did you read the SRC architecture and SRC components? I think you already read this. I don't think we have any. I'm trying to get him the compact. Oh yeah, okay, good. Go read all that. Are these the old? Oh, these are the fake ones? No, these are real. Okay. Good. That should give him the compact. So that should definitely get him a compact. Oh, there it goes. So he's compacting. Okay. Now that you've compacted, please re-onboard as in the general role. So he's finishing off summarizing, and then he's going to re-onboard. and then he'll continue from where he left off. So you can see he took that 220,000 tokens and he basically forgot everything, right? Not everything, but most of it. And then he's going to read the attention board. He's going to go back, read his tickets, and all that good stuff. And and then he gets to continue from where he left off. So this is a big use case for here, right? So okay, he's going to recertify. Let's go back to this guy and see what he's did. So he is running more PyTests. Okay, ran into an error. Tests are probably out of date. Missing AST import. Okay. Failures. Failures everywhere. 16 fails. He's going to patch that, and then we'll see if it works. So, like, him implementing this isn't a big deal because the code already exists for the code gen. So he's just translating the code into AST. And I wonder if it's going to be the same speed. I'm assuming that it's going to be slower. And I'm assuming that I'll have to roll this back because my code was really good. Codex wrote the code gen for that. We'll see what happens. I don't know. So he is implementing all this stuff. Now, I wonder if I think this guy's probably on step 600. So he is. I really want to like this video is getting super long, and I think we're gonna have to cut it off here in a second. So I want to make sure that I can show you guys something here. Okay, let me go back to VSC so you can see what's going on here. Now he's re-onboarding, right? This is the intended effect, right? The intended effect is, oh, I picked up trade-off is you got to pay up front, right? 60,000 tokens, but you get these skills. So that's great. Great. And then he's going to do the attestation field, which is like, I have to certify him. Policy driven. You can't gate with tools here, so you gotta do stuff like that. So he's rereading his templates and he's rereading everything. And these are interview tasks actually. So his task here was to interview me and find out what I want because these are design, kind of like a design meeting. Like I have the agent with me. We're planning out like the architecture and what I want to add. Then I have two more milestones I want to hit in this repo before I finish, and then I can release it. Right? That's my goal. So I got to implement all this, and I'm using it. This is way better than using like GPT Web, like GPT Pro. Like I prefer talking to Codex on my computer. It's way better for me, and so he's declaring what he read. And then I approve them. I go like this. I go, great. Now, one thing about Codex in here is you can steer, which is great. Please go reread your epics, stories, and tasks, and attention. I should have steered properly. Okay, and then let's go back to this guy, and then let's see if he is able to get this going here. So he's going to patch that. I think he did creation context already, so he just has one step to do here and we're done. So he's thinking about what to do about the error. I wonder if this even runs. Did you break it all, Codex? I mean, Gemini? Did you break the whole system? Oh yeah, he broke it. He broke it good. I wonder if he's actually gonna be able to get this to run. Let's see. This is pretty complicated. If he can get it to go, I'd be surprised. Like he didn't actually getting this to go in like 30 minutes. I doubt he can pull that off. I don't know. Like I don't think it's like maybe he can pull it off. Maybe he can pull it off. So, and then here, let me go back to this guy so you can see Codex again, and then we'll call it in a second here. Okay. So he's going over the documents. He's reading the epics. He's reading the attention board. He's found everything, and he's updating the time. I think there he's yeah he did that here. Okay, and cool, great. So he's caught up now. That's pretty good. Like what are the trade-offs to this, right? You could just assume he knows some of the things that you think he knows, right? Because you really can't tell. Like what exactly is in the algorithm for compacting? Like what's being retained? What is going to be saved? What's in the fuzzy? What's going on there? We don't know. We don't know. That's the only answer as good engineers, developers can say. Like we actually have no clue, right? We have no access to the compacting data. We have no clue what GPT finds important because really I think this is my guess. What's happening here is the system prompt goes in and says to GPT, I want you to summarize everything that happened here. Hey, you could try that yourself, right? Have GPT take 200,000 tokens and then tell them, I want you to summarize everything you know in less than 5,000 tokens or less than 10,000 tokens and see what that looks like. Because that's what he's doing. Like it's not much more than that. So this is why this stuff's very important, right? Like you can see you have this, you have the tickets, you got all this good stuff, right? And not any implementation of this, right? You could have GitHub, you could have Python tools set up to access GitHub, get tickets, change them up. You can have a multi-agent framework set up like that, where you have 10 agents doing this stuff. Boom, boom, boom. Some creating, some doing this, some of code, some testing. Sure, right? And the mechanics don't change. You're still managing context. You're still managing state. You're still managing tokens over time. The mechanics stay the same. So let's go back to this guy, and he's still implementing things. Okay. I think it's very likely he can't do it. Now, it'd be a shame if I had to end a video like this, but look, odds are we have to revert this, right? But it's really showcasing the system. That's the whole point here, right? You can see he's implementing the epic here. He's implementing this stuff. He's going through the story. He's implementing evidence. So this is really the point of what I'm doing here. The success or failure is not important. Odds are he's going to fail. Like taking CodeGen and modifying it, I don't know if he can pull that off. So I'm betting he fails. I'm betting he doesn't know how to do it, and I'm betting I revert this, right? Because I don't think he can properly do this. So I'm running my own test, and I see he thinks he's done, right? Oh, he's actually still thinking. Okay, we'll give him a chance. Yeah, he's essentially building the same thing I had in CodeGen, but in AST. And this is very advanced Python stuff. Like without AI, I'd probably struggle a lot with this stuff. It's not easy. CodeGen on its like agents are the best at CodeGen. They are built around that, right? Like that this is clearly their strong suit. So using an agent for CodeGen is the right thing to do. It's essentially dynamically generating the Python code because it executes faster than having a normal method. Sounds really weird, but you dynamically generate all of the components for the execution of the code, and then it builds. Um, so he is dealing with an issue, oh, with a bug. He duplicated ast.ast, and he's trying to patch it. Yeah, so he's adding helpers, process helpers. I mean, I don't think this looks any nicer than my code gen. I think this looks just as bad. And it's more structured. I think that's a good thing. This does look more structured than um, the way it was. Now, the reason why it's just one big chunk of code, it runs faster. So this is a hot path, and I do want this thing going as quick as possible. Um, so let's see if it runs. I'm actually unit testing on the other side here. No, you can't get it to go. So phase 12 executor takes 0 position arguments, but 3 were given. I don't even think I used that. That's just literally on his side. Okay. I clearly picked the wrong example for this, right? But maybe not. I think at this point you understand like what this is for. I'm pretty sure you get it. We're almost at an hour here, so I'm sure this is not going to be nice for YouTube. No one's going to watch it because people don't like long form, and I don't know if this is even interesting because it's like I'm just hopping between like windows, and this is my code, not really applicable to everyone, right? So I'm not really sure if I can even trim this down, but yeah, he doesn't even know what to do. I think running tests via poetry. Oh, he's starting to forget things. Okay, so here's the beginning of our issues, right? Let me demonstrate something now. He has no idea what's going on anymore. So he's done. He's cut off. And did we run out of time? Oh, hold on. Clearly, the UI is broken. Um, did you finish? And what step are you on? I wonder if we ran out of tokens because that demo's been pretty long. No, he's still going. It's just the UI's bugging out. I think he forgot where PyTest was. I don't think he knows what's going on anymore because he's been using it the whole time. What is your current step ID? 633. Okay. So you forgot where PyTest is? Yeah, he doesn't know what's going on anymore. So, truncation. This is the issue. He doesn't know where PyTest is, even though he's been using it the whole time. He forgot. He literally forgot where it was. Okay. So, let's scroll up. Pretty sure he's using it. Expand all. Path. PyTest. Testing. Deltas. He set up a temporary variable for the env. I think VM new is what we use. So he forgot. Let's see. Anyways, I think we should end the video now, but so yeah, truncation, right? The moral of the story is he is truncating information. He forgot how to run PyTest. He doesn't know. He legitimately doesn't know. And he doesn't know what he's doing anymore. He doesn't know what's going on. He's starting to get confused. And you can see all the mistakes. Oh, he got it going. Okay, so he figured it out. Okay, so here's the best part. Okay, we're gonna ask him. Okay, what checkpoint are you on? So checkpoints are save points that the application uses, and you can roll back from those areas to like I think it uses get. You can just roll back. He's not answering a question though. He's locked in, super locked in on his task. So okay, I should turn this into a stream. That'd be better. What? He wants to write a text file? What is going on here? Okay, so I don't think he knows what's going on anymore. Y0 is identified. Analyzing 0. All right, we're done. We're gonna pause. We're gonna pause. Pause all operations. Okay. How much of step 1 to 300 do you remember, or has it been truncated by your system? See if he knows. Yes, the raw turn-by-turn history of steps 1 to 300 have been truncated by my system to manage my context window size. However, I haven't completely forgot what happened. During the truncation process, my system has provided me with a detailed summary of those steps. Our earlier objectives, refactoring, phase 12, AST. Okay, okay. You see how big of a problem this is? So we're talking about implementing a new runtime for a DI container, right? A new resolution system, okay? That's very difficult work to set up. It took me weeks to get it right, right? Okay, now imagine you're implementing this, and it's going to take a long time because there's a lot of code in there. There's a lot of different steps to get this going. And then the data gets wiped. It's similar to the Codex truncation, but it's in the background. It's hidden away. You can't see when it happens. You can ask the agent what happened. He's going to say, "Oh yeah, I forgot everything." Like here, "Oh yeah, I forgot everything." So this is the funny part, right? Okay. So read the attention board and read your tickets, and let's pause and talk about it. So he didn't know where PyTest was. He didn't know where so many things were. So this is kind of where I don't even think he knows where the attention board is. Maybe let's see. Oh, he figured that out because we skipped the onboarding. So the onboarding was supposed to happen at 500. We were supposed to re-onboard, but he was locked in. He was locked in. He's like, "I'm finishing this. We're gonna get this done." He knows where the epic is at least. So some of the data is still there. And here's what we need to do. So at this point, oh, so he's remembering. He's remembering. Okay, so now, okay, okay. And do you see the attention board needs you to re-onboard as so I want him to remember what it means to work in the system because he's not gonna be able to remember. Now, this is what I'm talking about. These are the challenges of like tier one, tier one. Like he thinks Context Compass is a tool now. Like he's all over the place. He doesn't know what's going on, right? So look, he's trying to execute the tool Context Compass. That doesn't exist. Okay, go into Gemini, Context Compass, onboard as general role. Go do that. He doesn't know what's going on anymore. We missed a window. He vaguely remembers some of this stuff, and this is the story. So now like I've been doing this for months, almost a year, and I'm pretty used to this stuff, right? But you can see the challenges of agentic AI. We're talking one AI, not 10, not 20, not 50, right? This is one AI. These are the issues that we face. Agi is not coming. You are not going to lose your jobs to AI. Like these are the modern issues we have, right? So of course you can use this for automation. Of course you can use this for various amazing things, right? I'm not saying you can't, but we're not there yet. And yeah, I think this is a good note to end it on. Even though he wasn't able to finish everything, I think this really summarizes the point of Context Compass, the point of all this stuff, the point of everything. Um, and yeah, so another issue, he'd never actually read all the skills, not just those, every single general skill. He tried to wiggle his way out of it. He tried to trick me. That's what happened here. So this is called performative compliance. Okay, all these different little things exist. So what he did here, let me just explain this, and then I'll go over it. So he thought he thought he could read some of these skills. There's around 30 of them. He thought he could read some and get away with it, right? He read the Agent MD, a couple of the important ones, and he's like, "Yeah, that's good enough. That's good enough." But it's not good enough because he needs to know all these other things. He needs to understand all these skills every time. They're not long. It's like 1,000 tokens. It's fine. He's got to do it. And did it skip ahead? Okay, cool. Great. Okay. And this is a constant effort, right? Constant effort here. So I hope this helps. I hope you liked this video. And if you enjoyed it and you actually stayed to the end, you're awesome. So thank you very much for watching. This is Context Compass. Download it on GitHub. Give me a star. That'd be awesome. I just want 1 star. Like, get a couple stars would be awesome. So, yeah, this is basically why I built it. You can see the struggles of Agentic AI. You can see the difficulties of it all. This is very difficult stuff. So I'm hoping this makes some people's lives a lot easier, and it definitely helps me. I will be making more videos with this, more demonstrations of it. So thank you very much for watching. This is Synaptic, and you have yourselves a great day.